Thank you again for sticking around, and we're about to do the deep dive on policy implementation, and so it's my true pleasure to moderate this panel discussion with some distinguished officials from DOE. Earlier we heard from Undersecretary Menzies, and it was helpful to kind of get that high-level policy approach, but these are the guys in the trenches, doing the heavy lifting, doing the implementation. And so our policy doers here will be able to give us a little bit more context on what's happening a little bit closer to the ground level, at least from a federal standard and viewpoint. I'm particularly excited about this panel because we have a good cross-section of what's happening at DOE represented here between fossil energy, nuclear, loan programs, and energy efficiency and renewables offices. And I think that that's important because as we've talked about several different times throughout the day today, we're in the midst of a massive energy transition here in the United States. Climate change has been brought up more than once, but we're not operating just as the United States. There's a global energy market out there, and part of what I want to be able to do is chat with these gentlemen about what we're doing well here in the U.S., what some of those global markets and opportunities might look like, and how we're positioned, how the federal government is helping to position states and the private sector to head in the right direction. For me, it's a little bit personal. I spent a lot of my career working internationally with U.S. Agency for International Development and a lot of developing countries in Africa and Latin America. And there, folks are focused on not on the first kilowatt of energy, focused on how they can, what that first bit of generation is going to be in a lot of rural communities. Here in the U.S., part of our big challenge with making this energy transition is that we have 100 years of built infrastructure that we're working with in some cases, but we're also working against. There's a lot of resistance, there too. And the U.S. energy picture is tremendous and dynamic, and it's impressive what we've been able to do. Acting Administrator Wheeler justifiably noted that carbon emissions are down by a lot. My friends at the Business Council for Sustainable Energy put out a fact book. Definitely grab one if there's still some available at the back that help tell this story and the narrative of what's going on in the clean energy economy. And it's good here in the U.S. The transition is going well. Emissions are down, renewable energy is up, jobs are up. These are all the trends that we definitely want to see. But DOE, and in fact what Secretary Perry has articulated in a couple of different ways, whether it be through new energy realism, an America First energy policy, energy dominance, however you want to talk about it, it is by definition positioned not just domestically, but globally. And what I'm very interested in understanding and learning from our panelists here today is what's the difference between U.S. energy markets, the technologies that we're seeing deployed already, and what we may see deployed in the near future. So what I'd like to do is introduce our distinguished panelists here from right to left. Steve Capanna, Director of Strategic Priorities and Impact Analysis in the Office of Energy Efficiency and Renewable Energies. Angelos Kokkinos, Director of Advanced Fossil Technology in the Office of Fossil Energy. Brad Williams, Senior Advisor in the Office of Nuclear Energy. And Doug Schultz, Director of Origination for the Loan Program Office. What I'd like to do is first start off and provide each of you with 5 minutes, give or take, to talk a little bit, introduce yourself a little bit. But what I'd love to hear is what's going on in your office, what's new, what's changed over the past few years. Many of you have been working in these programs for quite some time, and so I'm interested in what's new. And if you don't mind getting started, Steve.
Sure. Thanks very much, Charles.
Sure.
So, as Charles mentioned, my name is Steve Capanna. I'm the Director of Strategic Priorities and Impact Analysis in the Office of Energy Efficiency and Renewable Energy. We're a cross-cutting analytic group, so my purview covers all of EERE's technologies. EERE has three broad pillars. So there's energy efficiency, renewable energy, and actually sustainable transportation. We're not EEREST because I guess that's too many letters, but our technologies improve energy security and resilience, lower emissions, and offer Americans a broader range of energy choices. Within EERE, we have three primary objectives. The first is to increase the reliability of our technologies and to improve their integration into the existing energy system. The second is to drive down the costs of these technologies through our R&D efforts. And the third is to develop partnerships and collaboration opportunities with the private sector. And our focus on early stage R&D enables U.S. industries and entrepreneurs to develop and deploy innovative energy technologies and maintain the competitive edge that we need to keep our role as a leader in the global energy economy. As Charles mentioned, we've had a lot of success in recent years. I think Undersecretary Menzies earlier today mentioned some of the cost reductions that we've seen in renewable energy technologies, which have been really impressive over the last few years. Over the last decade, the median cost of wind developments has fallen by by more than 50%. And on solar, it's actually been by closer to 2/3 compared to where it was 10 years ago. The Department of Energy set what we thought at the time was a very ambitious sunshot goal to achieve 6 cents per kilowatt hour for utility scale solar by 2020. We ended up actually meeting that goal 3 years early, which was a huge success. And so we've doubled down on that, and we're actually we've set new 2030 sunshot goals of 5 cents a kilowatt hour for residential solar, 4 cents for commercial, and 3 cents for utility scale solar, all by 2030. And because of these cost reductions, in large part because of these cost reductions, we've seen an enormous growth in renewable energy over the last several years. In 2017, renewables actually were made up about 20% of total energy capacity, about 18% by generation, which is roughly 10 times larger than it was in 2007. So over the course of a decade, we've just seen an enormous change. That's wind and solar generation, sorry, was 10 times larger than 2007. And we've seen more than half the capacity that went in 2017 from renewable energy sources. We also have seen good improvements in energy efficiency. LED lighting has fallen by, the cost of LED lighting has fallen by about 90% since 2009. And we know that efficiency is having an effect as over the last decade, after basically since the history of the power sector in the United States, slow and steady growth, not even always so slow and steady growth in electricity demand. Over the last decade, electricity demand has been relatively flat. Now, some of that's due to structural changes in the economy, and some of it's due to the financial crisis and the recession. But even after the recovery and the GDP growth that we've seen since then, we really haven't seen a parallel increase in electricity demand. So we've just been increasing energy productivity, and we may have succeeded in, to large part, decoupling electricity demands and economic growth. I'll also, being mindful of time, what do I got, like 2 minutes or so? Okay. I'll just mention from some voluntary programs, one voluntary program that we've done that's been a great success is the Better Plants program, which works with U.S. manufacturing. Manufacturing represents about 30% of the energy use in the United States. And Better Plants is a voluntary private-public partnership program that works with companies to reduce their energy costs, increasing their energy productivity, saving jobs, and increasing competitiveness. The program has partners at nearly 3,000 facilities across the United States and all 50 states and DC and Puerto Rico. And savings over the last 8 or so years have represented more than $4 billion in energy cost savings in these industries. Finally, I'll just briefly mention in transportation, electric vehicles, which have also seen huge drops in lithium-ion battery prices by about 80% since 2010. And just a word about looking forward, those are all accomplishments that we had in the past. We know there's still a lot to be done. As I said, the integration of these technologies into the grid still has some work to do, and we're beginning to think about that. We're also trying to develop new technologies to be deployed in the sort of medium and long term, things such as offshore wind, concentrating solar power, enhanced geothermal systems, wave and tidal power, biofuels for marine and aviation purposes, and trying to really get the most out of new technologies like 3D printing in the manufacturing side. So I think I'll leave it there for now, but looking forward to the rest of the panel and the discussion to come.
Thanks, Steve. A lot of cool technologies and things certainly on the frontier. Angelos, I'd like to turn it over to you and fossil energy, which sounds not just old but ancient. And but tell me what's new.
And you're absolutely right. And the person that is representing fossil technology is also ancient and old.
Experience. We
Literally.
prefer experience.
Anyway, I'm the Director of Advanced Fossil Technology Systems, which encompasses the Clean Coal and Carbon Management R&D program within the Office of Fossil Energy. The R&D portfolio is about $480 million in fiscal 18 and includes R&D programs in advanced energy systems, cross-cutting R&D and systems integration, carbon capture, utilization, and storage. I just want to, since you mentioned old and ancient, I just want to tell you that the Office of Fossil Energy and the Department of Energy has done quite a lot of work in reducing emissions from fossil power plants over the last, and I've been in this industry for 4 decades, over the last 4 decades. I actually went to graduate school on a ERDA scholarship to do work on emissions control in oil combustion. And we have been blessed with strong commercial success and return on the taxpayers' investment. For example, low NOx burners are installed in the entire fossil fleet. We have selective catalytic reduction systems. We have gas desulfurization systems that are installed in about 75% of the fleet. Just to give you an idea, according to the EPA, in 2017, we have seen an 85% reduction in nitric oxide emissions since 1980 and 75% reductions in particulate emissions since 1999 and 91% reduction in sulfur dioxide emissions since 1993. The DOE and Fossil Energy led the effort in basic R&D for mercury emissions control from fossil plants, especially for coal plants. We carried out full field tests on 50 U.S. power plants between the years 2000 and 2008. And mercury control has been installed in over 400 U.S. power plants, representing about 180 gigawatts, or about 2/3 of the existing fleet. So where do we go from here now? We have, in fossil energy, we have 4 major pillars for our R&D. One is to focus on the existing fleet. How do we improve its efficiency? And it's a different efficiency. It's the efficiency of generating power. So when I talk about efficiency, I'm talking about the efficiency of generating power, miles per gallon, basically. 2 is to look at what does the future fossil coal-fired power plant would look like. And I will talk a little bit more about it. 3 is carbon capture, reduce the cost of carbon capture. And 4 is, I'm a coal guy, but I'll talk a little bit about oil and gas, improve the efficiency of the upstream and midstream production of oil and natural gas. If you look at the EIA projections for the foreseeable future, coal will be a significant part of the U.S. and global energy mix. To that end, our office is making investments to ensure that we have the most efficient technologies available for these plants, and higher efficiency means lower emissions. The current fleet, the current fossil fleet, coal fleet in the United States is about 31 to 32% efficient, cycle efficient. Our goal is, with our future power plant, is to improve that efficiency from 31 to 32% to more than 40%. Our goal is actually 42%. That means a 30% reduction in fuel usage. That means 30% reduction in emissions. In the area of CO2, we have a robust CO2 capture, utilization, and storage program, and our effort is to reduce the cost of capture by 50% by the year 2030. Right now, we have invested significant amount of money, and the U.S. taxpayers have invested significant amount of money in this area, but we are looking to improve the current cost of CO2 capture from approximately $60 a ton removed to $30 or less by 2030. To that end, we're doing an early stage R&D. In carbon storage, we're looking at improving and predicting how CO2 would behave underground and how we can get better utilization through EOR. But we also invest in ways, investigating ways to utilize CO2 for value-added products. Mm-hmm. And that's, I think we can talk about that a little bit later. So in summary, one other thing in the CO2 area that I want to mention is that we have invested in the National Carbon Capture and Sequestration Carbon Capture Center in Alabama, where over 40 technologies for 7 different countries have been tested for capturing CO2 for over 100,000 hours of operation. That's more than 10 years of continuous operation. And in summary, I like to tell you that we're looking at a lot of transformational R&D that, again, provides lower emissions, reliable, resilient, and competitive power from fossil fuels, and particularly from coal in the U.S. and around the world.
Thanks a lot, Angelos. Brad, let's shift over to you. In the nuclear space, similar long history of nuclear deployment here in the United States, but a very different future is shaping up. If you could speak to us a little bit about the federal government's role in the nuclear energy space, that'd be great.
Sure, I'd be happy to, and thank you for having me here. I always thought it was cool saying that I was a nuclear physicist, but I think maybe working on dinosaur energy might be might be even cooler. But I work in our front office focusing on policy and technical and more strategic planning type activities, but previously spent 10 years in managing our technical R&D programs. And I'll tell you, right now is the most exciting, also challenging time for nuclear, but I think we are making a lot of progress. Being at an event like this, where we, being the largest source of clean, carbon-free electricity, that we are actually at the table being recognized during Clean Energy Week. You might think that, well, that's obvious. It's the largest source of clean energy, but many people don't realize that, and it's not often broadcast and not always considered in the policies that are focused on clean energy. So that's one of our main goals, is to level the playing field and create technology neutral solutions. So I think this is an excellent opportunity for that. But in addition to helping ensure environmental sustainability, nuclear energy is critically important for several other reasons. Obviously, energy security, it's the most reliable and resilient source of electricity with capacity factors over 90%, 93% of the time it's running. Pretty much only shuts down every 1.5 to 2 years for refueling, and then is quickly back up, providing that power, which also contributes to price stability because it only refuels very infrequently. You don't have to, you're not subject to frequent price fluctuations, so it helps ensure our electric bills stay consistent based on the amount that we use. Nuclear is also unique in its national security importance because of the potential dual use of nuclear technology. So maintaining a strong domestic nuclear industry is important here for our energy and environment and economic needs, but also around the globe. We need to ensure continued U.S. leadership. So that's another priority of ours. And then lastly, economic prosperity. Nuclear provides significant high-paying jobs, career-long jobs in a single location. It drives the local economies. I've heard local leaders say that in some instances their school budgets, 90% of them can come from the local nuclear power plants. So that's a big impact. So there's a lot of reasons. The focus here is on the clean energy benefits. So I'll talk about what we're doing from a technology standpoint to improve that. But our office is focused on 4 main priorities, mission pillars, as you might say. One is sustaining and extending the life of the current fleet. Our 98 reactors in the country currently provide about 20% of our electricity generation. And as I mentioned, the majority, close to 60% of the carbon-free generation. Those plants are aging, the majority of them have actually already extended their life from 40 to 60 years, and 8 reactors have announced intentions to go from 60 to 80 based on programs that we supported to support the technical basis for that, and they're working with the Nuclear Regulatory Commission there. We're also performing R&D to improve the performance of currently operating plants through advanced fuels that you can get more energy out of the fuel. And also they have enhanced safety features that may also improve the overall economics. And obviously we're also working on and focusing on a number of policy opportunities. I mentioned including nuclear energy and clean energy policies. 30 states, including DC, right now have renewable portfolio standards. A number of states, New York, Illinois, New Jersey, Connecticut, have recognized that they also need to include nuclear in their state-level clean energy policy and have implemented programs to do that. A number of others are considering it. We were in Pennsylvania yesterday. Their nuclear caucus had a hearing talking about the value of their nuclear power plants there. So lots going on there. But then shifting, our next priorities are focused on advanced technologies and the very exciting new opportunities for new nuclear reactors, both for electricity generation, but also moving beyond that to, a term I like to use is nuclear beyond electricity, where our advanced reactors, whether they are small modular reactors that can be built in a factory and have scalable power outputs, so you don't need to buy 1,000 megawatts at a time if that's not what you need. Maybe you need 50 megawatts, and in 10 years you need another 50. You can build those one module at a time. So it increases flexibility, scalability. It helps these new technologies can accommodate the evolving grid that does not need that large, stable base load, but needs something that can load follow or be more flexible as other sources provide power. Microreactors that are even smaller, that are in the 1 to 5 megawatt range, that could be used for very remote applications or islanded grids, or if you're a Google or Amazon or Facebook or someone that has a data center and needs that special, reliable, resilient, clean power to meet your goals, these small microreactors could be the choice. We're also looking at other non-water advanced reactors that can do lots of things beyond electricity. High temperature gas reactors, molten salt reactors that can provide process heat for desalination, to drive industrial processes, hydrogen production, which I just recently learned if you actually used hydrogen, you could decarbonize the steel manufacturing process. So there's lots of interest from those communities in getting that hydrogen from these nuclear plants. hydrogen fuel cells and work that we have with Steve's programs in ERE. I had the opportunity to ride in one of the fuel cell vehicles a year or two ago, and was asking why is nuclear an attractive option, and the answer was hydrogen produced by a high temperature gas reactor could be economic enough that you could fill up your car for half the price we currently do with gasoline. I'd love to spend $20 or $25 instead of $50. So lots of excitement there. Medical isotopes, not even in the energy or industrial sectors, but cancer, cures and treatments. Lots and lots of opportunities for these advanced nuclear plants. So that's really what we're focusing on, and using advanced techniques to build them, additive manufacturing, for example, factory fabrication to really bring the technology and jobs and supply chain back to the U.S.
Sure.
But then also our last priority is global competitiveness and ensuring that U.S. technologies are leading around the world.
Great. Thanks, Brad. And I'd like to get back to that in just a little bit. Doug, in the meantime, I'll turn it over to you in the Loan Program Office. At Citizens for Responsible Energy Solutions, I'm privileged to get the chance to get out to states, interact with a lot of businesses, some of them very small businesses that are working to develop the next generation of technologies, some of which we've touched on here. Talk to us about the Loan Program Office and how that differs from some of the other types of financing that DOE does. Go ahead.
Absolutely. So as Charles said, I head up the Loan Program Office on the origination side. The best way to think about us is we're the bankers, right? And so what we do is we complement all the other people at DOE that are on all the different lines, nuclear, fossil, renewables, et cetera. And we help bring technologies when they are ready to be scaled up. But because of gaps in the market for senior debt, senior lenders that traditionally finance large projects or large energy infrastructure type projects aren't able to be involved. And they're not able to be involved not only because of the risks involved, but because of they can't even understand the technology and spend the time to work through understanding that technology, because as a lender, one of the fundamental issues you have to think about lenders versus equity providers, lenders don't make a lot of money on their loans. And so the way you make money as a banker is by putting out a lot of loans, putting the money out and getting a return for that. If you spend a lot of time trying to understand a technology and it doesn't pan out, you have taken that time, that team that you have that should be out generating new loans, and they weren't generating loans, they were looking at new technology. So even if you haven't lost any money on a transaction, there's an opportunity cost issue. We're just the opposite. We are here to understand technologies, figure out how to de-risk them, how to allocate risks appropriately. We can get involved very early in the life cycle of a technology and potential projects to help developers of those technologies and projects to be able to see at the end of a development cycle that there is debt to be able to provide, which then provides a way for other participants to be involved. So you think about it, it's not just technology providers that are needed. It's who's buying the power. It's who's doing the construction, who's operating, who's putting equity in. There's a myriad of actors that need to be involved to solve very real world problems that if they don't have a view that the capital will be there at the end, they're not going to spend the time to do that. So we come in, we're fully staffed. So just to let you know who we are fully staffed with bankers and developers like myself, who have been out in the industry for most of our careers. We have full legal team, so full transactional attorneys. Most of them have been partners at law firms here in New York and Washington. We've got a full technical team, which is not only just the technical expertise, but also project management expertise. We have a full portfolio management group, which actually once the loans close, we're active monitors of transactions. Mm-hmm. So we're very engaged in what's going on and help be a good partner in terms of the projects that are moving forward. Environmental compliance, we have a full staff. So what we bring to the table are hundreds of years of experience out in the market pulling things together that other lenders just don't have the ability to do. So we structure these transactions. We work with applicants or potential borrowers to get transactions to a point where they are financeable. We're able to finance them on our own, so we can provide all the debt, or we can also provide capital, the ability to bring other lenders in with us. But the ability to be able to structure these, put them out in a way that the lending community would understand it, and even the equity community as well, they can come in once it's been validated and look at a transaction and then spend the time to actually diligence it themselves. So, in terms of successes, we've been involved in pretty much everything that that you can think about energy related over the last 10 years. We've been involved in all the new nuclear developments, including the existing as well as all the new SMR technologies that are moving forward right now. A number of them are applicants of ours that we're working with. On the fossil, in terms of carbon capture and sequestration, we've been involved in a lot of what's been going on in terms of trying to take the technologies that everybody is developing and try and find commercial applications for those. On renewable, geothermal, concentrated solar, all the new concentrated solar plants that are out there are all things that we were working on and helped to fund. Wind, biotechnology, biofuel technology. It runs the gamut. Automobile manufacturing technology, and probably what we're best known for, and the one that shows the real way that we look at success for us is on photovoltaics. We got involved in PV when there were no large scale projects out there. There was Nellis Air Force Base. And there were a lot of developers and entities that were interested in doing solar, but no one could get them across the finish line and get them financed. We came in, we did the first few thousand megawatts on our own. We did the diligence, we structured them, we brought in the independent energy, we kind of taught everyone how to do the work on it. And did those on our own on our own balance sheet, essentially funded those, and then we actually, for our last two transactions, brought in the private lenders with us, who were then ready to actually take a little bit of risk, share due diligence with us. So we brought in insurance companies, lenders, and at that point, they were able to see how these transactions can be diligenced, how they could look at these transactions similar to the way they look at wind transactions and others that they were involved in, and we were able to step back and not do any more. And essentially what's happened is now we have, PV not only in the United States, but globally. It is something that there's a whole cadre of individuals that can help diligence these. Mm-hmm. There's lenders all the way up and down the tier, down to small lenders as well that are able to diligence these. And that's what we want to do. We're here to facilitate the private sector coming in, show how to get the work done, be replicated, and then step out and move on to the next technologies. And as I said, we see tremendous opportunities still in what needs to be done. Storage is still something, and it's not just battery storage. It's storage. There's many, many ways to store energy, and a lot of them are very innovative in terms of what people are trying to do. We're involved in that. Again, the new technologies in nuclear and fossil and offshore wind. So we see a tremendous opportunity to continue to move forward.
Great. Yeah, thanks for that overview, Doug. I think it's a very helpful, number one, but an important viewpoint to understand your office's function as validators for nascent technologies that could be the next big thing. I'd like to pick up, Brad, where you left off in terms of the international view. You don't need to be an energy expert to know that this country was built in no small way on nuclear power and coal. But looking at the U.S. energy market, it's a competitive market, and it's not a growing market. For all of the right reasons, energy efficiency is driving down energy consumption, and that's a key challenge that we face here that other countries don't. If you don't mind talking to me a little bit, and this question is primarily for Brad and Angelos, but how do you view deployment of these next generation technologies, whether it be small modular nuclear reactors here in the U.S. versus internationally, and even for a technology like carbon capture storage, I remember 10 years ago when I was working with U.S. Environmental Protection Agency on the geologic sequestration rule, there was a lot of interest globally and a lot of eyes on the U.S. to see what we were doing with this technology, and I'm not sure if that's still the case.
So I'll go ahead and
Yeah,
start.
go ahead.
So yeah, you're absolutely right. In the U.S., demand has remained relatively flat or even declining in some instances, but not a huge opportunity there. I think where we see that the potential domestically, again with the additional optionality of different size and power output reactors, but eventually as replacements. But internationally, there's significant growth. There's currently about 60 reactors under construction around the world. And several of those are U.S. designs that are being built, but many are not. And very quickly, countries like Russia and China are taking more of a leadership role and
Right.
overtaking us with what they can offer to these countries. And this can be a century-long relationship. So, as I mentioned, one of our priorities, we lead an interagency effort called Team USA, which are all of the relevant U.S. federal government agencies that have a stake in nuclear power, State Department, Commerce, NRC, DOE.
I like
NSA.
that, Team USA.
Yeah. And one of my colleagues just down the hall leads that effort. But it's focused on what can the U.S. do, what can the U.S. government do to help ensure that U.S. industry has a fair opportunity to compete against, in many cases, state-owned entities or state-backed entities.
Yeah.
So a lot of focus going on there. And one of the biggest things from a DOE standpoint is creating those new technologies that are economically competitive, that are right-sized, so to speak, for the communities. When I started at DOE 10 years ago, it was under a program that called the Global Nuclear Energy Partnership, which was looking at global expansion, and I was brought in to work on a program called Grid Appropriate Reactors. Fast forward a decade, that's small modular reactors. Same thing. It's unique applications that can't handle a gigawatt scale power plant. The other thing that we're working on in addition to the technology front is engaging partner countries to help them move forward with reducing their emissions.
Sure.
You might recall that just this past year, Secretary Perry launched a new nuclear initiative at the Clean Energy Ministerial. The first time, again, that nuclear was included in the clean energy international framework.
Yeah.
And the new initiative, the NICE Future, it's a clever acronym, is focused on working with countries to figure out how nuclear integrated with other technologies can best meet the global needs of countries. And that's just getting started, but I think that's a very, very exciting opportunity on the global front for a community like this.
Good. That's thanks for that viewpoint. And Steve and Doug, do feel free to jump in on this question. But Angelos, if you want to chat a little bit about maybe carbon capture storage, or but if you can keep it to 2 minutes so that we can get to a couple of other questions too.
There's a couple of things that we're doing, and it's a three-path parallel effort on this. Number one is we are looking at, as I mentioned earlier, the future fossil or coal power plant. What is going to look like? And the grid is changing, and as it was mentioned before, we're looking at smaller size, increased flexibility, but most importantly, high efficiency and near zero emissions. And that plays in very well with both the CO2 capture, but also plays very well with the international application. And what we see is the international activity in fossil energy is more focused on efficiency rather than CO2 capture.
Okay.
At the same time, we have also focused on, as I mentioned before, on reducing the cost of CO2. In the previous panel, it was talked about the CO2, the cost of CO2, and that is an impediment in getting this type of technology applied in the commercial sense. And so what we're doing there is we're looking at developing new sorbents, new solvents, membranes, advanced membranes that would allow us to, as I mentioned before, reduce the cost by 50% of what it currently is. Gotcha. And when you combine the lower emissions, because now that is from a high efficient unit to lower cost technology, now you're really reducing the cost even more than the 50%. Because gotcha. You have reduced the emissions by 30% to begin with. You're treating less kilograms or less pounds of tonnage of material. So that is our effort.
Great, thank you.
Steve, or Charles, I'm sorry. I would throw in just on the small modular reactor that there is tremendous interest, I think, in the community, and particularly municipalities that are involved, that are looking for long-term solutions, zero carbon, that can provide, not 15 years or 20 years, but 60, 80 years of level pricing. Sure. And those are communities that can support and make these long-term investments. And so we see it out there right now. I mean, we're involved with projects right now that are going through that. And I also think that, the NRC cuts both ways, in terms of it is viewed as a global standard in terms of a stamp of approval. Sure. And so many of our developers that are here in the United States that are looking at SMR technology, and there are many startups, there's a lot of VC capital being involved, lots of, as was said, all across the spectrum. These are technologies that can be built here. They're at scale. I mean, it can be built, in fact, and exported overseas. And so it's a tremendous opportunity. I think there's a lot there. And on carbon capture sequestration, I think the 45Q tax credits will be very interesting to see how that provides a market, a potential market for the CO2 and encouraging actual sequestration beyond some of the pilot projects that are being done by our FE group with Archer Daniel Midland and others. So I think there's a lot of activity on those two fronts that I think could be very interesting. And we're seeing that from our side, which is on the financing side as well. So
that's good to know and helpful to see where those pockets of demand are specifically. So one last question with the few minutes that we have for Steve and Doug here. The title of this panel is Spurring Innovation and Reducing Emissions. One of the biggest challenges that our country will face in terms of reducing emissions and achieving that next generation technology is in the transportation sector. Right. If you two wouldn't mind chatting a little bit about what DOE's engagement is in transportation from your office.
Right, you go for it.
Sure. So try to do a lightning round here. But I'll just say first, though, that although it's true that transportation is going to be considerably harder than the power sector, I do just want to mention that I think the industrial sector is going to be harder still. So it's worth keeping an eye on that. On the transportation side, EERE is working on a wide range of technologies, from increasing the efficiency of internal combustion engines, since we know that we're going to continue to sell petroleum using vehicles for the foreseeable future. So increasing the efficiency of both light duty and heavy duty vehicles. Also increasing the efficiency of EVs. We have a goal to have electric vehicles, the batteries for electric vehicles cost $80 a kilowatt hour, which is down about a third from where we are today, have a 15-minute charge time and a 300-mile radius. And we think that if you're able to do that, you'll eliminate a lot of the range anxiety that we get with the adoption of EVs. Sure. And along with that is the increase that we've seen in recent years in EV charging stations that are now publicly available, which is a big deal because it also gives people that confidence that they can charge even when they're not at home. Yeah. And then I'll also just mention, we do work on fuel cell vehicles, which is seeing some good growth, especially in California, and also in biofuels, specifically on cellulosic ethanol. And again, we're really looking at trying to achieve some biosubstitutes in the marine and aviation areas. One last thing I'll say is there's a really exciting new initiative called the Energy Efficient Mobility Systems, EAMS, which is looking at the transportation system as a system. And instead of focusing on what we traditionally focus on, sort of increasing the efficiency of a widget or of a specific technology, is thinking about how we provide transportation as a service. And this is in response in large part to things like Uber and Lyft, but also the potential for autonomous and connected vehicles, and thinking about how are we really going to be using transportation in the future. Are we going to, is everyone going to have a car? Are we going to have vehicles on demand? And how do we increase the efficiency of both energy efficiency, but also cost efficiency, and increase to access to these services to some traditionally underserved areas for mobility, so low income and senior citizens especially. Yeah. So we think this is a really exciting new area.
Thanks, Steve. Doug, do you want to?
Sure. Quickly, as you know, we've been involved in the auto industry from the beginning in terms of our program. We were involved with Tesla and Ford and Nissan early on in terms of, manufacturing of automobiles and the new technologies that were going on there. I think that, moving forward, we still see a lot of opportunity, but it's in maybe other areas that might not seem as exciting. So it's things like components. It's lightweighting of vehicles. These are very big capital intensive. It's things that work very well for debt from us. So high strength steel, high strength aluminum. A lot of things are going on that are not the flashy, the car that's being built, but it's all the other components and things that are going on to make them lighter, more efficient. There's also, I think that although we're not involved directly because of our statute, heavy duty vehicles, buses, trucks, tremendous opportunities. That's where most of the emissions are. I think there's a tremendous opportunity for financing there as well, given the structure of those industries. So I think, we think there's a lot of opportunity out there. There's a lot of things that are very interesting that are going on that most people might not even see.
Well, I appreciate all of your time to be able to come here and join us today and provide a glimpse into it. I'm a believer that the government shouldn't pick winners and losers, but I think what's apparent from this conversation is that DOE is providing a lot of support across the board so that individuals in the market can choose and get out there. But more than that we can assure American leadership in all of these different spaces too. So thank you for your work, and thank you for your time here today.